All right, so what we're going to do is we're going to split on each line, and then we're going to map. Actually, we're going to do a reduce, right? So we're going to reduce it into that hash. So we're going to do reduce into cards.new. Do each line. Then we're going to split the cards off. So we're going to say card and, well, okay. Card and I don't know if we want to call that numbers. Yeah, I can do that. I can say card header, card head, and card body. Head and body, sure. It's equal to line dot split on colon. Okay. Then we're going to say that the card number, I think what we can do, so there may be something in Crystal that lets you kind of chomp off the beginning. With prefix lchop. So try and remove, yeah, lchop will work. No, not quite. So we want to remove the card, but we also want to make sure that actually, do we really need to worry about the spaces, the prefix spaces? We may not have to. So we may just be able to say head dot l chop card space, and then turn that into an integer. That might work. Okay. So let's just maybe test that out. And okay, there's reduce actually has to be cards, and we have to say cards.merge, and then we'll put in the card number, and for now just an empty hash of, or let's just say card.new. There we go. Okay, and let's put cards and see what we get there. So right now we should just expect to see a hash with all the numbers in it. Yep, there we do. Okay, let's continue on then. Now we're going to try and get the cards that we have and the cards, or the numbers that we have and the numbers that we need. So we can simply do, first of all, split it into, we'll say, what do we call them again? Winning and half. Winning and half is equal to body dot split on pipe. And then we'll just reassign winning to winning dot scan, and we'll do a regex here that just gets any number of digits. And then we're just going to do a map on that to make sure that we get the actual value and then turn it to an integer. And we do the same thing with half. Cool. So now, instead of just this, we have card number is equal to a hash of winning, half, half. All right, let's take a look at what that does. Cool, very good. All right, we have our data structure. That was pretty straightforward. Now we're going to actually solve part one. So part one seems pretty straightforward here. All we're going to do is iterate over all the cards and then check to see what's the overlap between the winning and the half, and then take that overlap and do 2 to the power of that overlap. That's it. Okay, so we're going to do cards dot I guess we'll do a reduce. Reduce starting at 0. And we're going to do like a sum. Do, so you know what? We don't even need to, no, we do need to start at 0. Okay. So we're going to say that the sum, or what is it called? Yeah, we'll just say sum. Sum, and we'll say card, and the card here is a card number. I'm just thinking if I should do like a destructuring here. No, we'll do it later. Okay. So all we need to say is we're given a card, which is a key value pair. Yeah, let's destructure this and ignore the card number for now. Okay. So then we just need to take out the card winning and card have and try and find like the intersection of those. Let's see if there's some sort of intersection thing. Intersection. So there's a set intersection. Subset of sometimes an array just minus the other one will kind of give you let's just kind of search this up. Intersection of array crystal. Let's just kind of take a look at the array stuff here and see if we can find something that might give us what we want. Oh, look at that. Set intersection returns new array containing elements common to self and other, excluding any duplicates. Exactly what we want. So that's ampersand other. So I think we can simply do card winning and card have, I think it's like that. I think that's how you call it. Okay. Let's just do a puts right there. And then return back 0 for now, just so we can see what it looks like. Puts part 1. So we should see a whole bunch of arrays of various different lengths, and we do. So let's kind of spot check with the first one here. Or maybe one of the shorter ones, 36 and 56 for 1, 2, 3, 4, 5, 6, 7. Well, the input's pretty large, so I don't. There's a 56 and a 36 there. 36 and a 56. Yep, okay. Let's get a little spot check. Cool. So that gives us that. We just need to figure out the size. And then we just have to return back sum plus 2 to the power of power. What do we think power is? Probably that. Maybe. Nope. Expect argument to array to be array, not int 32. Let's try putting some parentheses around some stuff. Okay. Supposedly that's the answer. 473. Could be. Let's give it a try. 473. Oops. Not the right answer. Too low. So 473, too low. Alright. What might I be missing here? Well, we could try and actually replicate the example first. As a sanity check. Let's do that. Got 21 there, which is actually more than what we should be getting for the example. We should only be getting 13. Okay. So let's, in here, put this guy. All right, so we got 4, 2, 2, 1. Card 2 has 2 winning numbers. So I'm already doing something wrong here. No, card 1 does have 4. Okay, no, card 1 does have 4. 2, 2, 1 is it correct? 4, 2, 2, 1 is correct. But we're calculating it incorrectly here. So let's now put this thing and see how much we're scoring for each card. Six zero zero 3 2 2. Why are we doing that? That's not right at all. It's like completely opposite of what it needs to be. Okay, looks like this power operation is probably incorrect. Let's try that. Okay, that's correct. More correct anyway. Size minus 1. Give that a try. Minus 1. Cannot raise integer to a negative integer power. Use floats for that. So what was wrong with me just doing size? Size, if size is 1, we're doing 2 to the power of 1. If size is 0, then we're doing 1. Okay. So we can't do size minus 1. We have to do 2 to the power of size and then divide by 2. Is that correct? Divide by 2. That should give us our answer. Eight, 2, 2, 1. Nope, that's not right either. It's close, but the problem is the ones that are intersection of 0 should just be 0. So this is just math, and I'm struggling with the math of it today. So this is almost correct, but it's actually in the case of it being 0. So this could almost work, but we need to say well, to the power of nothing. There's nothing that you can do to the power of that will give you. They'll give you 0. But we need to score 0 for yeah, okay. I can math here. Let's see. That's almost correct. If size is 0, then we want to okay. Let's first just put this as its own parameter. We'll just say wins. We'll say wins is equal to that. And then we'll say if wins is greater than 0, and then we'll just do an else sum. And then we're just going to say sum plus 2 to the power of size minus 1. Okay, I think that should be fine. Nope. Wins is the correct one. Wins. $13. Okay, that's what we want. So let's comment that out and see what we get for part 1 from my input. Should be higher than 473, and it is. Very cool. Alright, that's part 1 done. Let's see how part 2 looks. Alright. There's no such thing as points. Instead, scratch cards only cause you to win more scratch cards equal to the number of winning numbers you have. Specifically, you win copies of scratch cards below the winning card equal to the number of matches. So if the card 10 were to have 5 matching numbers, you would win 1 copy each of cards 11, 12, 13, 14, and 15. Okay. Copies of scratch cards are scored like normal scratch cards and have the same card number as the card they copied. So if you win a copy of card 10 and it has 5 matching numbers, it would then win a copy of the same cards that the original card 10 won, cards 11, 12, 13, 14, 15. This process repeats until none of the copies cause you to win any more cards. Cards will never make you copy a card past the end of the table. Card 1 has 4 matching numbers, so you win 1 copy of the next 4 cards, 2, 3, 4, and 5. The original card 2 has 2 matching numbers, so you win 1 copy each of cards 3 and 4. Your copy of card 2 also wins 1 copy each of cards 3 and 4. Your 4 instances of card 3, 1 original and 3 copies, have 2 matching numbers, so you win 4 copies each of cards 4 and 5. Your 8 instances of card 4, 1 original and 7 copies, have 1 matching number, so you win 8 copies of card 5. Your 14 instances of card 5 have no matching numbers and win no more cards. Your 1 instance of card 6 has no matching numbers and wins no more cards. Once all the original copies have been processed, you end up with 1 instance of card 1, 2 instances of card 2, 4 instances of card 3, 8 instances of card 4, 14 instances of card 5, and 1 instance of card 6. In total, this example pile of scratch cards causes you to ultimately have 30 scratch cards. Okay, this is very different. I might not solve this on the stream, so just because it's in the morning and we got some other things going on, so I'll try and make a video later today going over my solution to this one. See you later.